Alrighty, I'm going to go ahead and get started. My name is Steve Thompson. I'm a solution consultant for VIAVI Solutions. We're the test set manufacturer and vendor for the JD785 CellAdvisor product. Today we're going to go through some various support issues and what's included in the packaging as provided out to the various markets. And this will include our technical support line, how to get the latest software and firmware updates, what bits and pieces are included in your kits. I'm going to give you an overview of the front panel and then talk about the functionality at a pretty high level that's in your box. We're going to have additional classes that will be about an hour a piece, and we're going to try and do them at least a couple times a week at different time zones. And these will run clear out into the middle of July. So hopefully there will be sessions that will cover all the in-depth feature and functionality of the box, because it does have a lot of features, a lot of test capability. For technical support, we do have a technical call-in number, and we will provide this slide deck out to everybody. And here's our technical support number at the very top. These folks are in from 5 a.m. to 5 p.m. Mountain Time, Monday through Friday. We also have an email node, so if you have questions, you can always email it into our diagnostic.tac at viavisolutions.com. There's also some solution support consultants similar to myself, and we're sort of spread out across the U.S. We've got them from Eastern to Pacific time zone. And these folks, similar to myself, can answer questions on the test set, but a lot of times when we're with customers, we won't be picking up our phone. So, you can always feel free to leave us a voicemail. We also have a video link. Roy Anderson recorded sort of a front panel overview, connector overview on a MPEG that you can download. It's at this web address. So feel free to go out and use any of these resources to be able to make good use of the test set. To get the latest firmware for your unit, and also we have some desktop software applications that run on the unit. You can get those at updatemyunit.net. When you log into that particular site, you're going to come into a page like this, and the CellAdvisor platform is here in the bottom left corner. There's, if you have other VIAVI solution products or JDSU products, formerly we were JDSU, you can get the latest firmware at this location. And when you log in, there's firmware here at the very top, but there's also release notes on what's included with that firmware, any type of new feature or functionality that's in the unit. We also have a set of recovery software and a procedure. So if you go to update your software and somehow it fails or doesn't complete and leaves your unit hung, you can download this recovery software, put it on a USB stick, plug it into your unit, and power it up, and it should recover the test set. I've not had any problems in probably the last 3 or 4 years, but we do provide that out on this site. We also have the user's manual, and I do recommend that you go ahead and grab the user's manual off this website. It has a lot of functionality information, a lot of how-to in the user's guide, everything from a quick start guide to remote control of the unit, how to set that up. And so there's a lot of information in it. We also have desktop software. We have some software called JD Viewer. It allows you to pull in test results onto your laptop that you've logged on the unit, and you can analyze those in this desktop viewer, everything from spectrum analyzer traces, cable and antenna analyzer traces, all those types of measurements that you can analyze on your desktop. We also have a software called JD Map Creator. So these units can actually be used to drive and log data with GPS coordinates, and you can output that data in a Google Earth format and be able to see it in Google Earth. You can also capture sections of town and make a graphic that you can pull into the test set to be used for interference hunting, interference analysis. We also have the capability to pull a building floor plan in a JPEG or that type of a floor plan into the test set. And it is a touchscreen test set, so you can walk around and map signal strength, check interference inside of a building also. And last but not least, we have the JD Remote software, which allows you to talk to the unit either over a LAN cable or the included Bluetooth connections that we have. So, and I'll cover part of that today. So again, this is a pretty valuable website. Definitely recommend User's Guide, and go ahead and get the latest versions of software here off our website. I think all the kits came with CDs. I know a lot of folks don't have a CD drive on their PC anymore, and I think these units were originally shipped last July. So the software that was shipped with them is now 2 or 3 versions back. So to get the latest and most current software, go ahead and go to the updatemyunit.net site here. So the other thing that we're going to provide Ericsson is, in addition to this presentation, we have a step-by-step procedure. It's a Word doc, well, it's a PDF that detailed description of how to connect up and do CPRI testing. So it gets you to the spectrum analyzer view on the CPRI, and it takes you through setting up all the interface for the various infrastructure vendors, whether it's Ericsson, ALU, or Samsung. We also have a quick measurement guide that we're going to send out, and I've developed a Bluetooth connectivity guide. So there's some instructions in the appendix of the user's guide, but I've gone through and created a PDF that has the actual graphics and what you need to do on the laptop side and what you need to do on the test set side to go through and be successful if you want to run the remote connections. So again, the user's guide has a lot of useful information. It's probably your primary go-to for how to do specific measurements or how to connect up and make the most use out of your test set. It has everything from all the signal analysis types of technology that are supported in the test set. So your units are fully functional for GSM, CDMA, EVDO, UMTS, LTE, both FDD and TDD. They also have WiMAX functionality, so you can connect up and do WiMAX testing. I know there's not much of that left here in the U.S., but there's step-by-step procedures for each of those technologies under the signal analysis portion of the user's guide. There's also over-the-air measurements for each of those technologies. And so it details the specifics on each measurement. So again, we're going to have coursework over the next several months that will go into each of these subjects. But for now, if you want to go in and use the test set, the user's guide is a very good source for being able to get up to speed quickly. We also have cable and antenna sweep information, everything from swarm measurements to return loss, distance default, line loss of cables. We do have some CPRI information in the user's guide for both CPRI. The units are also capable of OBSI. I know that I've talked to a couple people that have had some OBSI in their markets from some older infrastructure. There's also fiber inspection capability, so it takes you through how to set that up. There's several types of power meters that are available for use with this test set. We'll get into that as far as the optical power meter that comes with a unit. You can also use the RF import along with the attenuator that comes for measuring power. And we do support the JDSU or VIAVI RF power meter little dongle. It's a USB-based dongle. And so all 3 of those are supported in the test set. And again, the Bluetooth connection details are in the user's guide. So very important document. And it's searchable, so I highly recommend getting the unit. As far as the gear that comes with the test set, you've got a full-featured set of accessories that come with the unit. So the primary cable you're going to be using is this calibration cable, which is a phase-stable cable. Again, it's a consumable, so it's one of those cables that you'll use continuously, be screwing it on and off. It's used as a cal cable when you're connecting up to a regular antenna feed line. And this is a DC to 6 gigahertz cable. It's about 1.5 meters long, so about 5 feet. We also have a Y-Cal kit. is the one pictured here. This is an open, short, and load used to calibrate the test set whenever you're going to do cable or antenna measurements. And again, this is a DC to 6 gigahertz cal kit. The unit itself can sweep cables up to 6 gigahertz, so it's got a source inside it that can generate a signal for use in calibration. And cable sweeps distance to fault measurements up to 6 gigahertz. The unit also came with 3 Omni antennas, and starting at the longest antenna, that is your 806 to 896 megahertz antenna, so that will do all of your 800 megahertz LTE, CDMA measurements. Again, the mid-length antenna here is your 1900 PCS antenna. It sweeps everything from 1710 to 2100 megahertz. And then the shortest antenna is your 2.5 gig antenna, so it goes from 2300 to 2700 megahertz. So those are your 3 Omnis. I don't know if these are all labeled in the packages or on the actual antenna itself, but you can tell just by the length of the antenna which one is which. It also comes with a directional VIAVI antenna, and that's for use with this special test cable. It's got a type N on one end and an SMA on the other end. So this is a 700 megahertz to 4 gigahertz VIAVI. It's got a fairly good directivity at 1.85 dBd. And again, you've got the test cable that goes along with that. This VIAVI also has a little stand that screws on the bottom, a little triangular foot peg that you can use to set on a vehicle hood or set up on your dash to be able to hold the antenna so you don't have to hold on to it. We also have included a bunch of connectors, both bullets, barrels, there's DIN adapters, there's a pretty good selection of various connector types in one of the little cloth pouches inside the kit itself. So the unit also comes with a directional coupler. I don't know if there's a lot of places today where you have RF cables you can get to. Most of the RF today is at the top of the tower that runs between the remote radio unit and the antennas. But for any place that you have that at ground level, you can connect the directional coupler into the antenna feed line and have a coupled port that's about 40 dB down that you can connect directly up to your RF in port on the test set for a sample port if you need to make long-term measurements. And this is a 700 to 4 gigahertz unit also. I guess it is a 30 dB down instead of a 40 dB down. It's a 50 watt attenuator. The unit also comes with a 4-port combiner. So it's a type N in and type N out. And this allows you to connect up to 4 antenna feed lines together and have a single output. I've seen in some of the California markets where they have both CDMA and LTE at 800 that's combined as it runs up the antenna feed line. And so they'll take both the RRU from LTE and the secondary RRU for CDMA and combine those 2 signals. And this is another test-capable combiner here to be able to swap that out for testing. And again, this is from 700 megahertz to 4 gigs. So I think everything in your kits runs that same frequency span. The unit also comes with a directional power sensor. This is a USB-based power sensor, so it plugs into the USB port on the test itself, and it's a pass-through. So you take your antenna feed line, go into the input, come out of the output, and on up to the antennas. And this can do both average power, peak power, and you do get a swerve measurement off this, so it allows you to set the power. I don't know how often folks do that today, but it is included within the kit. We also have a 40 dB 100 watt attenuator if you're using it with the internal power meter on the test set. You can connect this up to the RF in port on the test set and hook your RRU output directly into this attenuator, and it drops the power enough to where you'll be able to connect up and read power directly off the RRU. Again, the max input power of the test set is plus 25 dBm, but this should keep the power level well below that, down in the 0 dBm range for making sure you don't overdrive the test set or damage the test set. The unit does have remote control capability, and this is through a Bluetooth dongle. So there's 2 of these within the kit. One plugs into the USB port on the test set. The second USB dongle plugs into your laptop. And there's some special software that comes with that called Blue Soleil. It's a small little CD disc that fits in with the USB Bluetooth puck. The longer antenna you see here is for higher gain. These units are rated at least 100 meters, so you can put this particular Bluetooth puck on your test set, have the tower crew take it to the top, and you can run it remotely from the comfort of your cab on your truck and be able to make measurements while communicating with the test set at the top of the tower. So again, there is instructions in the user's guide on how to use this, and I've got a secondary document that has a lot more graphics and step-by-step information for it. So the unit also has a bias T that is built into the test set. So this is used for sweeping cables running to the top of the tower where there may be a pole-top amplifier. And these pole-top amplifiers are powered by the center conductor of the RF feed line, which is a DC power supply. And so this blocks the DC from the RF in port on the test set. So it allows you to sweep through the antenna, power it up, sweep through it all the way to the antenna, and be able to do your standard antenna metrics measurements and sweep the cables at the same time. So again, this is built into the test set between the RF output port and the measurement port for the antenna measurement. So it's the center conductor on your test set. There's also 2 fiber taps within the kit. One is a multi-mode fiber tap and one is a single mode fiber tap. The way to tell the difference between the 2 is the color of the connectors on the test set. So here you can see the gray connectors on the front of the tap. This is the multi-mode unit. The single mode unit has blue connectors on the front of it. Again, there's 2 fiber jumpers with your kit. There should be an orange multi-mode connector that has gray ends on it, and then there should be a yellow single mode jumper that has blue ends on it. And so again, you can just match blue to blue, gray to gray. These pass both wavelengths of light. Again, you can use these for CPRI or for offsite testing. There's also a selection of CPRI FSPs or SFPs. I'm going to change that in my slide deck. SFPs, again, there's both single mode and multi-mode SFPs. There is an identifier on the SFP itself, but you can also plug these into the test set, and when you go into the RF over fiber screen, this is the first screen you come into. It's the SFP monitor mode, and it tells you the wavelength of the SFP that's plugged in and also the operating data range for the SFP. You can also read the optical power that you're seeing in and out of the test set. The unit does have 2 ports on it, and so you can test 2 at a time. Again, each one of these SFPs should start with a C on the front of it to signify it's a CPRI capable SFP. The units also come with an optical power meter. This is a USB-based power meter that just plugs into the USB port on the test set and allows you to measure the optical input power. We also have included a visual fault finder. So this is just a light source that you can use to shine up fiber. And so it can detect broken fibers. Basically, you shine light in one end and see if the light comes out the other end. You can also detect excessive bend in the fiber. A lot of times you'll see a little red light on the casing of the fiber as it goes up the tower, and you can see where the fiber is maybe bent too tightly or has too much of a bend in it based on the light not being able to go around, so it shines into the insulative jacket on it. The test kit also contains various fiber tips along with a Fiberscope. So this is our standard T5000i microscope. It's used for inspecting fibers. And so there's a barrel assembly that screws onto the end, and then you have interchangeable fiber tips for it. And your kit comes with 4 of them, so you've got a patch cord fiber tip, just a small end on it. You've got a bulkhead square fiber tip, and then a round bulkhead connector for the SC type of fibers. The unit also comes with a ribbon type fiber tip. And so this scope can be used with any of the JDSU products or VIAVI solution fiber testers that we have on the market. So the test set itself, this is the front panel view. Again, it does have an 8-inch high-resolution touchscreen display on it. Pictured here is the color display. This is the indoor mode. The test set also has both an outdoor and a nighttime mode. I'm going to go ahead and jump over to my test set here. So here's the test set running live, connected up to my laptop. And so you can change display modes on the test set. So I'm going to go over to my system button, which is the number 3 button. I'm going to go into my system configuration mode here and down to my display mode. And I'm going to select my outdoor mode. And this is a high contrast black and white display that will come on. And so this is fairly easy to see in direct sunlight. We also have a nighttime mode. So if you're using this in your vehicle at night, you don't want all this bright light shining in your cab. So this gives you a very toned down display that's easy to see at night in the cab of your vehicle. You can still read all the labels and see the display. So again, 3 different operating modes for the display: full color, nighttime, and outdoor mode. As far as the test set buttons and knobs, there's 3 different kinds of buttons. We have hard keys. They're the ones along the bottom of the display. These are fixed function keys. Everything from frequency, amplitude, setting your resolution, bandwidth, and these give you the same menus every time. The mode key is the primary key for getting back to a known starting point. It's like the home key on your phone. We also have what's called soft keys, and these control the menus on the right-hand side of the screen. So as you use the hard keys to change modes or to go into any of the settings on the test set from frequency, amplitude, these menus change, and you can use the soft keys to select those menus. We also have a numeric keypad on it, and these also have 11 hotkeys. You can see on each one of the keypad buttons here there is a secondary function. So on the number 1 key we have measure, the number 2 key we have trigger, the number 3 key is system key, and so each of these have a primary function that is used on the test set. Each of these is also backlit, so you can turn on the backlighting if you're working at night to be able to see the various keys here on the test set. We also have a rotary knob for quick menu selections, along with up and down arrows here, left and right arrows. You can use these for indoor mapping, be able to control a cursor on the screen or move up and down menus on the test set. The primary keys you're going to be using are going to be the mode key, frequency key, and amplitude key. So those are pretty self-explanatory. The mode is going to take you back to the home screen. Frequency is where you set all your frequency or channel information, and amplitude or scale is where you're going to scale up the display itself to make it where you can see the measurement centered in your screen. Two other primary keys you're going to use are the number 1 measure key and the number 4 setup for each of those measurements. So when you go in and select mode and select a measurement type such as spectrum analyzer, there's multiple measurements under the spectrum analyzer. And so to select those, you go into the measure key here. So the 5 primary keys you're going to use are the mode key, frequency, amplitude, measure, and measurement setup. You'll also notice that there's an indicator menu item here in the header of the screen. 1 tells you what mode you've actually selected. So here it's set to LTE. So the user's gone in and went to the signal analyzer and selected an LTE measurement. And then under the LTE measurement suite, they've selected the control channel measurement. And this is the screen they get with that. So again, you can always tell where you're at on the test set here based on the mode that's selected and the measurement that's selected under that mode. So again, the user is also selected, you can see here, the measurement setup key, and so it gives them the various measurement setup items for this control channel measurement. The input and output and ports for the test set, starting at the left, we've got our power supply here. There is a headset jack on the test set. So when using things like a power meter, a lot of times your test set is down at one location and you're over working on your laptop setting power. And so here you can actually, from the power meter screen, you can set an audible tone that changes whenever you get into the pass-fail regions. And so it'll actually change tone on the signal generator so you can hear that. So if you're in a radio room where there's a lot of fan noise, those kind of things, you can't see the test set, you can put a headset on and be able to listen to the tone change on the test set and know when you have it in the correct range. We also have both a host USB port and a client USB port. We also have an Ethernet LAN port. That's what I'm running the remote connection over today. I have a crossover LAN cable going between my test set and my laptop that I'm using for connectivity to run the unit remotely. These test sets also have the capability that you can plug this unit in at a fixed location, connect a LAN cable up to it, and remote into the test set. So we do have customers that are using this today at auditoriums and arenas around the country. They set one of these test sets up and just leave it as part of the infrastructure on the site. And before any event or big sporting game, those types of things, they can remote into the unit, use the spectrum analyzer functionality and the technology functionality to do a quick sweep and test of the site to make sure there's no RF problems or interference problems at the site. And again, they can do that over the LAN port. We also have 2 SFP ports, both the port 1 and port 2, so you can plug in various SFPs for testing with the CPRI or OPSI capability. We do have 3 type N connectors on the top. The 2 on the left are for antenna measurements. Basically, we've got an output port that can make single connection return loss, distance default measurements. We also have a transmission port here that's an RF in port, so you can measure gain or loss through an amplifier or a cable. So you can output a signal from the left-hand port and measure the input on the right-hand port. We also have a general RF in port that's used for the spectrum analyzer or any of the signal analyzer measurements. The unit also comes with a U-Blox GPS capability, and this improves measurement accuracy. You can also use the GPS for providing coordinates for interference analysis and hunting. You can also map any of the signal levels that are supported through the technology, such as GSM, UMTS, CDMA, EVDO. So from the signal analyzer, you can go in and actually have a route map in the test set loaded and have it log data. So for LTE, it'll provide you RSRP, RSRQ, SINAR measurements as you drive around at street level. And you can record that data with GPS coordinates and then output to a coverage map that you can import or visualize in Google Earth. Again, it does have some external trigger ports here. I have connected these up to the RF out on an eNode B before on the baseband unit and synchronized the test set to the eNode B. I can also use this GPS to test the GPS antennas on the site and the GPS timing at the site. So a lot of capability just within the ports on the test set. So I'm going to jump into the measurement modes now. So if I select the mode button in the bottom left corner after booting the unit up, it's going to show me the various test modes I have. So I've got spectrum analyzer, interference analyzer, signal analyzer. I have cable and antenna measurements. I have RF over fiber. Today you have CPRI enabled on your test set. You also have a channel scanner, and if you go to the More menu, you're going to see at the top there's going to be a power meter and a fiber test capability. Now the fiber test will be grayed out unless you have your Fiberscope plugged into the USB port. So underneath each one of these measurements, there's various sub-measurements. So right now I'm in the spectrum analyzer, spectrum view, and I'm just in the general mode. So you can see the spectrum analyzer is highlighted here. I've also got my signal set to a center frequency of an LTE carrier. I've got about a 20 meg span as the default span on the test set. So again, that's some of the various information on the main screen. Again, if I was using a channel standard, I'd have the channel number and the band in. The unit does come with a preamp that you can turn on. You can also set attenuation values, and you can set an external offset on it. I do have timing on internal. If I had my GPS antenna on, I would be seeing a little green antenna or yellow antenna here. Again, power supply, it shows you the battery charging level here on the front screen too. So here is my actual spectrum analyzer interface. So I've selected the spectrum analyzer interface. I have the standard spectrum measurement, and then I've pressed the number 1 key on the keypad, which is my measure key, and this shows me the list of spectrum analyzer measurements I can make. So I've got channel power, occupied bandwidth, I have a spectral emissions mask, an adjacent channel power, I have a multiple adjacent channel power measurement, and if I go to the More screen, I've got spurious emissions. It does have AM, FM demod capability, so this time of year with the NCAA tournament, you can listen to the latest ball game while you're working. It does have a field strength meter. Again, you do have a route map with the spectrum analyzer, so you can connect your GPS antenna up, pull in a graphic that shows you geopositioned information on your local area using the JD Map Creator software, and you can map your signal strength around a route that you drive, or you can pull a building graphic in and map signal strength of the building. We do have a dual spectrum analyzer capability. It's basically a split screen along with standard RF PIM detection capability in the test set. We also have an interference analyzer in the test set. So if I go to the mode button and select my interference analyzer, right now I have the spectrum measurement loaded. But I also, if I select my number 1 key, once I'm in the interference analyzer, the measure, I have multiple types of interference analysis that I can do. I have a spectrogram. I can do an RSSI measurement. I have an interference finder interface. So this allows me to do a triangulation method. Again, you pull a graphic in of the local area you're going to be testing interference in, and you can plot 3 different positions with an azimuth, a line drawn across the screen that will have a small little triangle in the center where the interference source should be. We also have dual spectrograms, so it gives you basically a split screen, so you can either look at 2 uplinks or an uplink and downlink signal off the same unit. We also have a radar chart. For signal analyzer information, we have all these technologies supported on your test set, everything from GSM, WCDMA, full LTE support for all the various bands, CDMA and EVDO support, And on the secondary screen, we have the WiMAX capability. For LTE, FDD, primary measurement, again, is a spectrum analyzer measurement when we first go in, but we also have RF analysis capability. You can do power versus time, so you can do frame alignment measurements. You can look at modulation analysis. These are direct connect measurements for the modulation analysis. We also have an auto measure button for LTE. So if you have a DAS system, you can go in and connect up to an RF out port or a coupled port on the DAS, and you can run a series of conformance tests on that DAS to make sure you have good signal coming out of the baseband unit that's being input into the DAS system. We also have a power statistics measurement. If we go to the secondary screen, the unit does support carrier aggregation, so you can look at up to 5 different carriers all tied together. I know carrier aggregation is being turned on out in the markets today. You also have full over-the-air measurement capability, and then there's the capability to turn on RAN performance. I don't think this is licensed on your boxes. For the over-the-air measurements, you do have a channel scanner, and again, you can turn this on and it'll identify various channels out in the network. We also have an ID scanner that if you're tuned to a specific carrier, it will pull in all the PCIs that it sees from that specific location. So if you had, say, a CDMA measurement turned on, running over the air with your ID scanner, you would see all the various PNs that are available in that particular location that your antenna is picking up. Again, you have similar types of over-the-air measurements for GSM, UMTS, LTE, both FDD and TDD. You also have control channel measurements, so you can look at your primary and secondary sync channels for LTE. You can look at the format indicator channel, both the reference signal measurements, and you have full EVM and power for each of these types of control channel measurements. Again, you can look at the amount of data that's being transmitted. It's similar to a spectrograph, only it's looking at which resource blocks are firing off at which times and keeps track of it as a flowing chart across the screen. And you can also run a route map over the air. So again, you can pull a graphic in of a city location, drive around and make measurements over the air and plot the data onto a route map, and it measures RSRP, RSRQ, sine R values. It gives you an ECI NOT on the secondary sync channel. So a lot of information you can pull out and use to help diagnose issues with your LTE network. For cable and antenna measurements, there's a full suite. We have a reflection measurement, return loss, a couple different types of distance default measurements. We have a one-port cable loss. If we go to the secondary screen, we have a two-port cable loss and a Smith chart. Again, the two-port gives you both phase and, you can do either a scalar measurement or a vector measurement for the two-port measurement. We also have full fiber inspection capability with the Fiberscope. So this is the same Fiberscope that comes with any of the other JDSU or VIAVI Solutions fiber test equipment. Same basic menu, everything from a test button, you can freeze the frame, you can change the profile and tip information, auto center's on by default, you can zoom in or zoom out, both high and low magnification. We have the same controls on the Fiberscope itself, so you don't actually have to interact with the test set. Once it's plugged in, you can just use this as a view screen. We have the zoom in and zoom out button. It's the one on the right. The knurled knob in the center is for focus. And again, the higher up the line it draws here in the little chart on the left-hand side, the better the focus is. And then we've got a little gray test button on the end. So again, you can plug your Fiberscope onto your fiber, zoom in on it, focus it, hit the test button, and they'll give you pass-fail information here, tell you what zone it is, whether you need to clean it, or whether you're good to go for testing. For additional classes, this is going to be the current schedule. So this is the week of March 14th. So this is just the overview and sort of the contact information where to get help. The week of March 28th, we're going to do a basic interface review again, how to navigate, input, output. We're also going to have spectrum analyzer and power measurement basics. So as we've traveled around to various markets, we find that there's a lot of people that have a lot of information on how to use a spectrum analyzer and what the measurements mean. Some people don't have as much knowledge, so we're going to go ahead and cover spectrum analyzer and power measurement basics. The week of April 11th, we're going to cover sweeping and troubleshooting cables, so we're going to look at all the various antenna and cable measurements. Week of April 25th, we're going to be doing basic LTE measurements, both over the air and direct connect, and this will include TDD setup for measurements. The week of May 9th, we're going to get into advanced spectrum analyzer usage, and that's going to include noise power, spectrograms, and how to use our various software packages, both Map Creator, JD Viewer, JD Remote. In the last half of May, we're going to do interference hunting. In June, we're going to go with PIM detection and spectrum analyzer usage to detect PIM. And then in June and July, we're going to have 2 sessions on CIPRI OPSI, both a beginning and a more advanced session on CIPRI and OPSI. So I'm going to switch over to my test set here now and give everybody a very quick overview of running the test set through the user interface. So I'm going to go ahead and select my mode button. And so here's the various measurements. So before I jump into any of those, I'm going to go into my frequency button here, and I'm going to select my frequency. So you'll notice there's a little blue box that appears here, so I can actually use the numeric keypad to do data entry now. So I'm going to go in and key in 751 megahertz. That's a signal I have here at my home office. And you notice it didn't change much. You can see a little bit of modulated signal here from resource blocks popping up. But I'm going to go into my amplitude and scale. And I'm going to just auto scale it to pull it up into the center of the screen. And now I'm going to go turn on my preamp. And now we can actually see the 10 meg carrier here in the center of the screen. I'm also going to go into my bandwidth button. The default resolution bandwidth is 100 kilohertz. I'm going to change that to 10 kilohertz. Right now my sweep speed is 12.57 milliseconds here on the left-hand side. But I'm going to go in and change my bandwidth here to 10 kilohertz. And you're going to see the sweep speed is going to slow down a little bit, but it's going to improve the measurement capability and the power level that we see the signal on. So now it's dropped from about -110 down to the noise floor of about -120. But it's taken 180 milliseconds to do the same measurement, so it's slowed it down about 10 times. Now I can take this all the way down to 1 kilohertz resolution bandwidth. But you're going to see that it's going to dramatically slow the update rate. So we also have a sweep button here on the screen. So I'm going to select the sweep mode and go in and go from normal sweep mode and turn on my FFT capability. And so we're going to go from 16 seconds to about 200 milliseconds now. So now we've got a usable noise floor down around -130 from my location, and we've got our LTE signal here. Again, I can change my dB per division by going into my amplitude, go to the More button here on the bottom, and change it from 10 dB per division to 5. Go back and do a little more auto scale here. And now we should have a pretty good display of the test set. Yep. Let me jump this down a little bit here. So there's our LTE signal we're going to go analyze. So now that I've got my signal set up, I'm going to go back into my mode button. So again, the spectrum analyzer is what's loaded. So if I go to my measured key here, it's going to show me what measurements I have for my spectrum analyzer. Again, I've got a lot of different things I can run. Hit the more key here. So here's all my spectrum analyzer measurements. If I want to go in and look at this with my LTE analyzer, I can simply go to my mode button, select my signal analyzer, and select my LTE FTD. You'll notice it'll change here in the top. I've got my mode as LTE FDD. And right now I have the basic spectrum analyzer view, but you notice my signal is no longer on the screen here. And that's because this spectrum analyzer sets up independently from the one we just did. So it has the right center frequency here, but I can go in and turn on my preamp. I can also, so there's our signal starting to pop in. I can also go into my bandwidth here, and I can turn on some averaging. So I'm going to go ahead and auto scale this. There we go. So now we have a very similar type of measurement. You notice you don't have quite all the same bandwidth settings that you do with the standard spectrum analyzer, that once you're into the LTE FDD spectrum analyzer, there's some slightly different settings on this. But again, now that I'm in the LTE measurement mode, I can select my measure button here, the number 1 button. Yep. Measure mode. And here's all the various measurements I can perform on that LTE signal. So everything from modulation analysis, power versus time, RF analysis. I'm going to go into my secondary screen here and go to over the air since I'm not connected up to the test set or to the Node B. And I'm going to go into my ID scanner. And this is going to show me what PCIs I have. And then it's going to give me measurements on those PCIs. So I'm seeing 2 PCIs from this specific location. There, it dropped down to 1. So it's got my PCIs, it's got RSRP, RSRQ, so it's got all the various information. So the over-the-air measurements are designed to be used with your Yagi antenna and have you parked in the main beam of your sector of interest. And you want to be about 100 meters back from the Node B or from your antennas. And that's optimum for having good dominance for the specific sector you're hunting for and good signal quality and signal power levels. So again, I can go into my over-the-air control channel measurements, and I can evaluate all the control channel settings for that particular sector. So everything from primary and secondary sync, I've got my broadcast channel information, my format indicator, and both reference signals, RS0 and RS1. So I have an EVM measurement, power measurement, phase details. Again, if I had my GPS antenna connected up, I should see a lot more accurate measurements here. Again, for datagrams, this will tell me how active the site is. Again, I can see which resource blocks are firing off here. And based on the color scheme I'm seeing here, I can track that over time to see how busy the site is and which resource blocks are being utilized by users out in the network. I also have my route map, so I can select my route map. And I do have a route map of the local area I'm sitting in here. Again, I can plot data, my RSRP, RSRQ, SINR values, ECI NOT values as I'm driving down the road here using my GPS for coordinates. Or I can select my measurement setup here for this particular route map. And instead of using the GPS, I can actually tell it I'm going to point to the position I'm at. And here's the item that it's going to plot on the screen. It still logs all the other information in the data file. That's what it's going to plot on the screen. I'm going to go ahead and hit my Start button here to start logging data. And now as I plot data, it's going to, again, I'm just clicking on the screen here because I'm telling it where I'm at. It's going to go ahead and plot data as I head down the road. When I'm done plotting, I can hit my stop button. It's going to go ahead and stop the logging. I can then go into save load and be able to save the data either to CSV format. And again, I can point to either my internal memory, I have a USB stick. I can point it to the USB stick. I can give it a file name here. Again, it's touch screen, so you just touch the characters you want and hit the save button. I can also save a screen capture of the dots themselves. And I can also edit the pass-fail limits I'm seeing here by going over to the limit button. So it'll allow me to change any of the limits for this particular measurement. So if I wanted to do the same for a CDMA signal, I could go into my signal analyzer, go to my CDMA signal, hit my measure key again, and it's going to give me a list of measurements that I can run on the CDMA signal analyzer, everything from spectrum modulation, RF analysis, auto measure, and over-the-air measurements. So again, that's a little bit of a flavor of the test set. Okay, well, I appreciate your time. I appreciate folks attending, and my recommendation is to gain access to a test set, and you'll find that these things are quite useful for determining interference, whether it's internal from CIPRI or from PIM, I should say, over the CIPRI link, or whether it's external and something you need to go mitigate out in the field. Also for looking at signals over the air, you can test out both CDMA and LTE over the air without having to open a cabinet. So it's surprising the times I've been out. I've been sitting in San Diego area, so I've used these a few times. It's interesting to go in and look and see where you have problems and being able to troubleshoot those. So appreciate your time, and if you have any questions, feel free to contact our support group or to contact any of the solution consultants directly. And hope you all have a great rest of your Friday and a great weekend. Thank you much.